Ladies and gentlemen, today we're going to talk about Notes 1.6. How do you prove that two triangles are congruent using congruent postulates and theorems? Okay, so a lot of this is you're going to be typing in. I will be providing some of this here, but I'll tell you what to write as we go along. So proofs, the thing with proofs is we're basically we're going to be given one or two statements, usually two statements, and from that, we're going to use some of the postulates we've already talked about before in order to prove a statement to be true. So our first one is, given that segment QS is parallel to RT and angle R is congruent to angle S, we have to prove that triangle QST is congruent to triangle TQR. So the first thing you want to do is you want to go ahead and write for your statements will always go on your left, and your reasons for those statements go on your right. Your first reason, or in some cases, first two reasons, are always given. So in this box, I want you to write given. Okay. Now we need to mark what we've done. Now I'm going to mark it here, but just on your Google slide, you'll just write in the information of the reasons. I realize it's kind of hard to mark these, but we're going to go ahead. So the first thing we're told with QS is parallel to RT. So what that means is we're going to draw, well, if you had a piece of paper, you would draw a triangle on this side and this side. This tells us that these two segments are parallel to each other. That means that they don't touch. So we've already talked about when we have two parallel lines that have a diagonal or a transversal that crosses them, we get a variety of angles like alternate interior, alternate exterior, and so on. For the purposes of these proofs, we're mainly going to be dealing with alternate interior angles. We're not going to be dealing with corresponding or anything else. So that was our first given. Our second given was angle R is congruent to angle S. So here's angle R here in the upper right-hand corner. Angle S is in the lower left-hand corner. Okay, so we do a little arc marks there to see that they're congruent. So that's our first given. Our second statement is angle 1 is congruent to angle 2. So that's congruent because if you notice, can't we draw a Z? I'm going to try to highlight it. Okay, you see how I'm drawing my Z? So that means what? Alternate interior angles. I just said with these parallel lines, we're going to be doing alternate interior angles. So that means that angle 1 is congruent to angle 2. Now you notice I drew two marks for angles 1 and 2 because we've already said R and S are congruent, so we don't want to confuse ourselves by saying 1 is congruent to R or S is congruent to 2. So that's why we use the two different marks. So here we're going to write alternate interior. Okay. The next thing we want to talk about is looking at QT. That segment, it's shared on by both triangles, QRT and QST. So we're going to write, we're going to do our mark here to say that they're congruent. So we're going to say that's congruent by the reflexive property. Because remember, anytime two triangles share a side, that means that they're reflexive. And that means that side, because they share it, it's the same, so it's congruent. So lastly, our proof statement for this first section is always going to be either one of our postulates, either ASA, SAS, AAS, and so on, or SSS. So now we want to label our parts. So remember I told you we're going to do one triangle at a time. Let's do this triangle here, QRT. So I have an angle here, and a side here. So all we have to put here is AAS. So AAS. All right. So it's very important, guys, that you mark your triangles, so your two triangles, so that way you can see what letters you're going to form. Okay. So that takes care of example number 1. Now let's move on to example number 2. Example number 2, we're told that AC is parallel to BD and AB is parallel to CD. So again, those are our givens. So we're going to write given for that reason. All right. Next, we need to go ahead and mark our triangles. All right. So AC is our first side is parallel, and it's going to be parallel to BD. So we're going to draw two triangles here. Next, we're told AB is parallel to CD. So now we're going to draw two triangles here, because again, we don't want to confuse ourselves by saying we have only one triangle and saying that all these sides are parallel when it's clear that they're not all parallel. Okay, so now the two triangles tell us the AB is parallel to CD, and the one triangle tells us AC is parallel to BD. So next we want to go ahead and start looking at angles. Now because we have these two sets of parallel lines, guess what we form? We form a Z. So you can do it forwards or backwards, okay? So with that being said, we're told angle 1 and angle 4 are congruent. So we draw a mark here and mark here. And that's going to tell us that that's going to be alternate interior angles. So hopefully we're starting to see a pattern here that when we're talking about these triangles, we're going to be talking about alternate interior angles. We're not going to do exterior or corresponding or consecutive interior. We're going to be doing that. All right. Statement 3 says that angle 2 and angle 3 are congruent. So again, we're going to draw 2 marks here for angle 2 and 2 marks for angle 3 because we're saying that they're congruent, but they're not congruent to 1 and 4. So again, alternate interior angles. Okay, now with these reasons, guys, you can repeat reasons. The only reason you don't normally repeat is your given, because usually the given statements will be in one statement, as opposed to that. But sometimes we may see some in a few minutes where your given statements might be on 2 different statements. And the proved statement is only going to be written once. But anything in between can be written more than once, depending on what your situation is. All right. So now we're told that AD is congruent to AD. Now, again, just like our first example, you see these 2 triangles share a side, which is here. Okay. So that means we're flexive again. Now, we have triangle ADC is congruent to triangle DAB. So now we will need to label one of our triangles. So this time we're going to do the bottom triangle. We have an angle, a side, and an angle. So again, that's ASA. All right. Does anybody have a question? Well, sorry, I can't ask questions. I apologize. So used to teaching this live, so I have to remind myself that you are going to be watching this later, and you can't necessarily ask a question. All right. Now let's move on to example number 3. Example number 3 says Q is the midpoint of PS, and Q is the midpoint of RT. So again, our first reason again is given. Okay. So now we need to mark our sides. All right. So we're told that these 2 are congruent to each other, and this is congruent to this one. Okay. So now we're told that PQ is congruent to QS. So that's PQ here, and then I'll kind of highlight it. That's PQ, and then that's QS. So this is the definition of midpoint. Okay. Now, again, when we go to QT, which is this side, and QR, again, we're going to say the same thing. So we're going to say definition. See what I was saying about repeating? So sometimes you can see things repeat. Sorry, Mr. Harper, I'm not spelling correctly today. Okay, so that's the definition of a midpoint. All right, so here on your next test, you may not always be given the statement. You have to give it based on the picture. Now, if you notice, what is this that Mr. Harper likes to wear a lot on Mondays and sometimes Tuesdays if it's that particular day? It's a bow tie or vertical angles. Now, you can't just say angle Q. When you have more than one letter, you have to say all the letters. So we're going to start off. Now, again, this will be provided for you on your form, so you don't have to do this. But angle PQT is congruent to angle SQR. And this is by vertical angles. Okay, so remember the bow tie is just to help remind you but we actually call this theorem vertical angles, okay? So please, please, please do not try to say bow tie on the test, okay? So again, that's congruent to that. So now again, we're going to pick one triangle. I'm going to say side, angle, side. So that's SAS. All right. So now we move on to our fourth example. It says triangle UVUX is an isosceles with legs UV and UX. W is midpoint of VX. All right, so now we need to mark our side. So first of all, our reason is given. Our first reason is given. So now let's go on to, it says UV. Well, let's first of all mark our sides. I apologize. So because it's an isosceles triangle, that means UV is congruent to UX. All right. And because W is the midpoint of VX, that means that this side is congruent to this side. All right. So now let's look at our statement. UV is congruent to UX, okay? So here you're going to write definition of isosceles triangle. And I'm going to go a little bit above it, but your text box should be big enough for you to fill that in. So it's going to be definition of isosceles triangle. Then we go on to VW is congruent to WX. This is definition of midpoint. All right. So now we want to look at statement 4 and see what it happens. You notice that they share a side, right? UW. So you're going to write UW is congruent to UW. Again, this will be provided because your equatio isn't working like I want it to. All right. So that means because they share a side, that's reflexive. And we're going to go ahead and mark it here. And look at what we have here. We have a side, and a side. So that's going to be SSS. All right. So again, guys and ladies, that the point of a proof is we're going to be given a statement. I'll use the number 4 example. We're going to be given some statements, as you can see right here, and we're trying to prove that this statement is correct. That's all we're doing proofs. That's what the idea of proof is, like proving, proving something to be true or false. In this case, in all our cases, it would be proving something true. So we have a backside to this worksheet. So if you will watch the second video, it'll help you to complete the second one, and then you'll have some problems you'll work on yourself. Talk to you in the next one. Bye.